Dear students, welcome back to a new mathematics session. In today's session, we shall discuss a new chapter, that is sequences and series from your NCERT textbook. Let's move on to the topic. Let's consider some patterns of numbers. 10, 20, 30. Next 3, 33, 333, 3333. The next is 2, 3, 5, 7. Next is 10,000, 1,000, 100. And the fifth one, 4, 11, 16, 33. And just go through these given patterns and try to find out the next numbers. So here you can see in the first one, 10. Next term is 20. Means adding 10 to get 20. Again, if you add 10 with 20, you will get 30. Means surely to get the next term we have to add 10 with this 30. Means 30 plus 10 is 40. Again 40 plus 10 is 50, 60, 70 and so on. Then here when you check, first term is having 3. Second again one more 3 is added. Then here one more 3. That means 3 threes. Here 4 threes. So next one will be 5 threes, 6 threes and so on. Then here you can see 2, 3, 5, 7. Visibly it is quite clear that prime numbers. So the next prime number, that is 11, 13, 17, etc. Here you can see first one is having 1, 2, 3, 4 zeros. Next one is having 3 zeros, means 1 zero reduced, divided by 10. Then 10,000 divided by 10 is 1000. Then 1000 divided by 10 is 100. Then 100 divided by 10 is 10. Then 10 divided by 10 is 1, 1 divided by 10 is 0.1 and so on. Means dividing with 10 each term to get the next term. Then what about here 4, 11, 16, 33. Means here when you observe, visibly there is no rule available for us to find out the next term. So it is a question mark. What is the next term? Because no rule is available to find out the next term. Simply there are 4 numbers it is kept. Here first 4 sets when we consider, each set is having a specific rule to find out the next term. Here in the first set we just add 10 to get the next number, and here just we put additional 3s to each term to get the next term. And here these are prime numbers, that is a rule, prime number from 2 onwards. And here means we have divided 10 to get the next term, dividing 10 with the previous term to get the next term. Means there is a specific rule here. So this type of patterns, this type of arrangement is called sequence. So here there is no rule is available for us, so it is very difficult to find out the next term. So let's define sequence. A sequence is an arrangement of numbers in a definite order according to some rule. A sequence is an arrangement. You can see here all these numbers are arranged in a definite order. Definite order means you see it defines a particular position in a definite order according to some rule. Each one is having a rule. Rule we have discussed before. In the first case, if you consider adding 10, then we denote the terms of sequence by A1, A2, A3, etc., AN, etc. This is the representation A1, A2, A3, etc., AN, etc. The subscripts denote the position of the term. Means here A subscript is 1, this one. So this is the first position. And A2 means this is the second term. A3 means this is the third term. AN, this is the nth term. The nth term is the number at the nth position of the sequence and is denoted by AN. Nth term means at nth position in a sequence, and it is denoted by AN. The nth term is also called the general term of the sequence. So the nth term is represented by AN, and the nth term is the general term of the sequence. General term means by using that particular nth term, by replacing the values of n, we can define the sequence. Like A1 we can find out, A2 we can find out, A3 we can find out, and so on. Replacing n and substitute the corresponding values 1, 2, 3, etc. Then we will get the corresponding terms. So the nth term is also called the general term of the sequence. For example, 2, 4, 8, 16, 32, etc. up to 1024. So you can see here 2, then 2 square is 4. then 2 power 3 is 8, then 2 power 4 is 16, 2 power 5 is 32, and so on. So here A1 is 2, A2 is 4, A3 is 8, and A10 is 1024, means A1 the first term, then A2 the second term, and A3 the third term, that is 16, and so on. Here when you check the rule, if you want to find out the rule, that of course it is not necessary here, but again let me explain to you the rule. So here 2, next number is 4. How do we get 4? 2 plus 2 is 4, but 4 plus 2 is 6. The next term is 8 here. So there is some other way we have to think. It means 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, and so on. This is the rule. So hope it is clear. There are some important points which we must note. A sequence containing finite number of terms is called a finite sequence. Means the number of terms of a sequence is finite, countable, then it is called a finite sequence. Example 2, 4, 8, 16, 32, etc. up to 1024. So here 2, 4, 8, first term, second term, third term, and the last term also mentioned. So because of that it is countable. Since the last term is there, it is countable. So it is a finite sequence. The sequence is called infinite if it is not a finite sequence. If it is not a finite sequence, means the number of elements we cannot count. For example 3, 3.3, 3.33, 3.333, and so on. So this is an infinite sequence because last term is not there, it shows an etc. here. Then in some cases an arrangement of numbers such as 1, 1, 2, 3, 5, 8, etc. has no visible pattern, but the sequence is generated by the recurrence relation given by A1 and A2. First two terms are 1, then A3 is A1 plus A2. Means first two terms adding means you will get the third term. And this sequence is called a Fibonacci sequence. It's a very important concept, this one, Fibonacci sequence. So let me explain once again. So this is called the Fibonacci sequence, 1, 1, 2, 3, 5, 8, and so on. So visibly there is no rule, but it is defined under this rule. First two terms are 1. You can see here 1, 1, and the next term is getting by adding the previous two terms. Means A3 is we are getting by adding A1 plus A2. So A1 and A2 is 1 plus 1 is 2. Next 3 we are getting by adding the previous two terms. Means 2 plus 1 is 3. And next we are getting 5, adding 3 and 2, previous two terms adding them, we are getting 5. Next 8 we are getting, adding the previous two terms, so 3 and 5, we are getting 8. So such an arrangement is called Fibonacci sequence, 1, 1, 2, 3, 5, 8. Once again, first two terms are 1, and third term is getting by adding the previous two terms, means 1 plus 1 is 2. The next term is getting by adding the previous two terms, means 2 plus 1 is 3. The next 3 plus 2 is 5. Next 5 plus 3 is 8. So this arrangement of numbers 1, 1, 2, 3, 5, 8, etc. that is called Fibonacci sequence. A sequence can also be regarded as a function whose domain is the set of natural numbers or some subset of it. So in terms of function also a sequence is defined. It is a function whose domain, means input values, is the set of natural numbers or some subset of it. Next I am writing a new number pattern. Here the first one is 10 plus 20 plus 30 plus 40 plus 50 plus 60 plus 70 plus etc. Means previously we have separated this one by using commas in terms of sequence definition. Now I use plus symbols, means 10, same numbers only, but just I use the plus symbols, 10 plus 20 plus 30 and so on. And the next one is 3 plus 33 plus 333 plus 3333 plus and so on. And the third one 2 plus 3 plus 5 plus 7 plus etc. and so on. And fourth one 10,000, 1000, then 100 plus everything is plus 10,000 plus 1000 plus 100 plus 10 plus 1 plus 0.1 plus and so on. So you can see the difference between the previous one means what we have defined, the examples which we used to define the sequence, and this one is here we have taken the sum. So this type of arrangement, that is called the series. So let's define series. Let A1, A2, A3, etc. be the sequence. Means A1, A2, A3, etc. be the sequence means there is a rule. Defined rule is there. That is why it is called a sequence. Then the sum expressed as A1 plus A2 plus A3 plus etc. is called series. A1, A2, A3, etc. be a sequence means if we are taking the sum A1 plus A2 plus A3 plus etc. the sum expressed as called series. As before, how we defined in sequence, in series also there are finite series and infinite series. Means a series is called finite series if it has got finite number of terms. Means the number of terms are countable, then we can say that it is a finite series. Series A1 plus A2 plus A3 plus etc. plus AN is abbreviated as sigma k is equal to 1 to n AK. This symbol means sigma stands for summation. Here we are taken the sum in series, that is A1 plus A2 plus A3 plus etc. plus AN. Since it is representing a sum, in general we can write in short, we can write as sigma k is equal to 1 to n. K is equal to 1 to n means k means this stands for the position 1 to n, means the first term is 1 and the last term is n. First term comes here, last term comes on the top. Then AK, that is the short form. Next we shall discuss the exercise problems. Exercise 9.1, first question. Write the first 5 terms of the sequence whose nth term is an is equal to n into n plus 2. Nth term means a general term is given to us, n into n plus 2. We are asked to find out the first 5 terms. Very simple question this is. First 5 terms means a1, a2, a3, a4, a5. So we need to find the first 5 terms a1, a2, etc. up to a5. An, that is a general form, an is equal to n into n plus 2. N is equal to 1 if you put, you will get the first term. Means a1 is equal to 1 into 1 plus 2. Means n replace and put 1, then 1 plus 2. 1 into 1 plus 2 is 1 into 3. 1 into 3 is equal to 3. Next is putting n is equal to 2. When we put n is equal to 2, a2 is equal to here 2 into 2 plus 2. So 2 into 2 plus 2, that is 2 plus 2 is 4. 4 into 2 is 8. Then next is putting n is equal to 3. So a3 is equal to 3 into 3 plus 2. So 3 plus 2 is 5. 5 into 3 is 15 that we have got. Then putting n is equal to 4. Replace n and put 4. We'll get the fourth term. That is 4 into 4 plus 2. N replace and put 4. 4 into 4 plus 2. That is 4 into 6. 6 4s are 24. Then putting n is equal to 5. A5 is equal to 5 into 5 plus 2. 5 plus 2 is 7. 7 into 5 is equal to 35. So we have got the first 5 terms of the sequence as 3, 8, 15, 24 and 35. Next we shall discuss the second question. Write the first 5 terms of the sequence whose nth term is an is equal to n divided by n plus 1. So we need to find the first 5 terms. Generally we can represent it as a1, a2, etc. up to a5. Putting n is equal to 1. So a1 is equal to 1 divided by 1 plus 1. N replace and put 1, that's all. 1 divided by 1 plus 1 is 1 by 2. Next is n is equal to 2. If you put a2 is equal to 2 divided by 2 plus 1. So 2 divided by 2 plus 1 is 2 divided by 3. Next n is equal to 3. If you put a3 is equal to 3 divided by 3 plus 1. 3 divided by 3 plus 1 is 3 by 4. Next is n is equal to 4. If you put 4 divided by 4 plus 1. That is equal to 4 by 5. Next n is 5. We can put 5 divided by 5 plus 1. That is equal to 5 by 6. So the sequence is first 5 times 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6. Next there are 2 questions, question number 3 and question number 4. These 2 questions you will try it as homework. Next we shall discuss the 5th question. Write the first 5 terms of the sequence whose nth term is an is equal to minus 1 the whole power n minus 1 into 5 power n plus 1. We need to find the first 5 terms as a1, a2, a3 and a4 and a5. Then an is minus 1 the whole power n minus 1 into 5 power n plus 1. Here calculation we need to be careful. The process remains the same. Replace n, put the corresponding position number. So putting n is equal to 1, a1 is equal to minus 1 the whole power n replace and put 1. 1 minus 1, 5 power 1 plus 1. That is written. that is minus 1 the whole power 0 into 5 square. 5 power 1 plus 1 is 2, 5 square. Minus 1 the whole power 0, that is 1. Any quantity power 0 is 1 into 5 square. 1 into 5 square means 5 square, you know that 5 into 5 is 25. Directly from here, directly we can come to this answer. It's not a problem. This is given for explanation purpose, these 3 steps. Minus 1 the whole power 1 minus 1. Minus 1 the whole power 0, that is 1. 5 power 2, that is 5 square, 25. 1 into 25 is 25. Directly we can write. The next is putting n is equal to 2. So a2 is equal to minus 1 the whole power 2 minus 1 into 5 power 2 plus 1. Then minus 1 the whole power 2 minus 1 is 1 into 5 power 2 plus 1 is 3. Minus 1 the whole power 1. Power is an odd number, so minus 1 will be coming. Into 5 cube. 5 cube means 5 into 5 into 5. Or else we can directly write 5 cube as 125. So minus 1 into 125, that is minus 125. As I said before, from the first set itself, we can come to the first step itself, we can come to the answer. It's not a problem. The next is n is equal to 3. A3 is equal to minus 1 the whole power 3 minus 1 into 5 power 3 plus 1. Replacing n and put 3. Then minus 1 the whole power 3 minus 1 is 2 into 5 power 3 plus 1 is 4. Minus 1 the whole power 2 minus 1 the whole square. Power is an even number, so it is plus 1 into 5 power 4. 5 power 4 means multiplying 5 4 times. That means 5 into 5 25, 25 into 5 is 125, 125 into 5 is 625. Okay, if you know mental calculation, do it, or also write and multiply. Putting n is equal to 4, that means a4 is equal to minus 1 the whole power 4 minus 1 into 5 power 4 plus 1. It's written minus 1 the whole power 4 minus 1 is 3 into 5 power 5. Minus 1 the whole power 3, that is power is an odd number, so it is negative 1. So minus 1 into 5 power 5, minus 1 into 5 multiplying 5 times, we will be getting as 3125. There is a minus sign outside, so minus 3125. Please multiply and write, please do not copy. The next is n is equal to 5. Because we are asked to find out the first 5 terms, replace n, put 5. That is minus 1 the whole power 5 minus 1 into 5 power 5 plus 1. Then minus 1 the whole power 5 minus 1 is 4. Minus 1 the whole power 4 is 1 into 5 power 6. Here I reduce the steps because first 3 steps the explanation, 4 steps the explanation was clear. So here I am reducing the step. Then 1 into 5 power 6, multiply 5 6 times. When you multiply 5 6 times, you will be getting 15,625. So the sequence we can write first 5 terms: 25 minus 125, 625 minus 3125, then 15,625. Next, the 6th question, write the first 5 times of the sequence whose nth term an is equal to n into n square plus 5 by 4. So this question also you will try it as homework. Move on to the 7th question. Find the 17th and 24th term in the following sequence whose nth term is an is equal to 4n minus 3. Here 17th term and 24th term we have to calculate. Nth term is given. Quite simple question. An is 4n minus 3. Equation number 1 we can make. Putting n is equal to 17, we will get the 17th term. So 17, if you put a17 is equal to 4 into n, replace and put 17. 4 into 17 minus 3. 4 into 17 is 68 minus 3, that is equal to 65. 17th term is 65. Next 24th term means n is equal to 24 we have to put. So a24 is equal to 4 into replace n and put 24. 4 into 24 minus 3. So 4 into 24 is 96 minus 3, that is 93. So the 17th term is 65 and 24th term is 93. Next, we shall discuss the 8th question. Find the 7th term in the following sequence whose nth term is an is equal to n square by 2 power n. Again, here also same thing, 7th term. Replace n and put 7. That is the only work. So an is n square by 2 power n. Putting n is equal to 7. A7 is equal to n is 7. So 7 power 2 divided by 2 power 7. Only thing is that here need to take little care while doing the calculation because here n as the base and here n is the power. So 7 square by 2 power 7, that is 7 square means 7 into 7 2 times. 2 power 7 means multiplying 2 7 times. 7 into 7 is 49. So here 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 32, 32 into 2 64, 64 into 2 is 128. So 49 by 128 is the 7th term. Move on to the 9th question. Find the 9th term in the following sequence whose nth term is an is equal to minus 1 the whole power n minus 1 into n cube. Same thing, 9th term. Here replace n and put 9. So an is equal to minus 1 the whole power n minus 1 into n cube. Label it as equation number 1. Then putting n is equal to 9 in 1. a9 is equal to minus 1 the whole power 9 minus 1 into 9 cube. So minus 1 the whole power 9 minus 1 is 8 into 9 cube. So minus 1 the whole power an even number means it will come as plus 1 into 9 cube. That is equal to 9 cube. 9 cube is 729. 9 into 9 is 81. 81 into 9 is 729. So the 9th term is 729. Move on to the 10th question. Find the 20th term in the following sequence whose nth term is an is equal to n into n minus 2 by n plus 3. Here 20th term you have to calculate. Just try this one as homework. Question number 11. Write the first 5 terms of the following sequence and obtain the corresponding series. Sequence we have to form and we have to write down the corresponding series. a1 is equal to 3, an is equal to 3 into a power n minus 1 plus 2 for all n greater than 3. So here a1 is 3, then I'll form an is equal to 3 a n minus 1 plus 2. That is what the statement is given to us. N is greater than 1 means 2 onwards we can use n. It is given that a1 is equal to 3. Since first term is given, that's why it is given n greater than 1 means more than 1. 2 onwards we can use. First n is equal to 1 value is given to us here. So an is equal to 3 into a power n minus 1 plus 2 general form. Then first 5 terms. First term already there. Then we can start from second term onwards means 2. N is equal to 2 in 1. a2 is equal to 3 into a2 minus 1 plus 2. This is suffix, okay? 2 minus 1 suffix. It shows the position. Okay. So 3a2 minus 1. 2 minus 1 is 1. So 3a1 plus 2. So a1 value is there with us 3. So 3 into 3 plus 2. 3 into 3 is 9 plus 2 is 11. Then third term putting n is equal to 3. Here a3 is equal to 3 into 3a here 3 minus 1 suffix it is 3 minus 1 plus 2. Remember once again I am telling this is the position, okay? Don't multiply it with something else. So 3 into a 3 minus 1 plus 2 that is 3a2 plus 2. a2 we have it is 11. So 3 into 11 plus 2. 3 into 11 is 33 plus 2 that is 35. Then putting n is equal to 4, a4 is equal to 3a4 minus 1 plus 2. That is 3 into a4 minus 1 is 3. 3a3 plus 2. a3 that is 35. So 3 into 35 plus 2. That is 105 plus 2, 107. Next is n is equal to 5. Means a5 is equal to 3a5 minus 1 plus 2. Means 3a4 plus 2. 3a4 plus 2. a4 is 107. So 3a4 means 3 into 107 plus 2. That is 323. So the first 5 terms of the sequence we have got. Then we have to write the corresponding series. So first 5 terms are 3, 11, 35, 107, 323. Sequence writing is quite simple. Just put a plus symbol in between instead of comma and write. So 3 plus 11 plus 35 plus 107 plus 323 plus etc. This is the corresponding series. Move on to the 12th question. Write the first 5 terms of the following sequence and obtain the corresponding series. a1 is equal to minus 1, an is equal to an minus 1 by n greater than or equal to 2. So n greater than or equal to 2. From 2 onwards we can use this rule. First a1 is given to us. First term is given to us. Given a1 is equal to minus 1 and an is an minus 1 by n. This n minus 1 shows the position. That is Very carefully you have to handle it. So putting n is equal to 2 means a2 minus 1 divided by 2. a2 minus 1 means a1 by 2. a1 we have minus 1, so minus 1 by 2. Next is n is equal to 3. So a3 is equal to a3 minus 1 by 3. a3 minus 1 means 2. a2 by 3. a2 the second one minus 1 by 2. So minus 1 by 2 by 3. That is minus 1 by 2. Division you change to multiplication. Denominator is 3. Take the reciprocal. So 3 reciprocal is 1 by 3. Multiply it. That's all. So fraction minus 1 by 2 in the numerator as it is you have to write. Then take the reciprocal of the denominator and multiply. So reciprocal of 3 is 1 by 3. Multiply it into. Then minus, there is only one minus. So you can just keep minus outside. 1 into 1 is 1. 3 into 2. 2 into 3 is 6. Minus 1 by 6. Then putting n is equal to 4. a4 is equal to a4 minus 1 by 4. a4 minus 1 means a3. a3 by 4. a3 is minus 1 by 6. So minus 1 by 6 by 4. Just again the same thing, minus 1 by 6 into reciprocal of the denominator. That is 1 by 4. That is minus 1 by 24. Next is putting n is equal to 5. a5 is equal to a5 minus 1. 5 minus 1 by 5. a5 minus 1 is a4. a4 by 5. a4 is here with us minus 1 by 24. So minus 1 by 24 divided by 5. Same operation. Minus 1 by 24 into the reciprocal of the denominator. That means 1 by 5. That is minus 1 by 24 into 5 is 120. First 5 terms we have got. That is, first term is there here minus 1. Second term is minus 1 by 2. Third term is minus 1 by 6. Fourth term minus 1 by 24. Fifth term minus 1 by 20. Then the corresponding series we have to write. Just put the plus symbol and write. That is minus 1 plus minus 1 by 2 plus minus 1 by 6 plus minus 1 by 24 plus minus 1 by 20 plus etc. Next, the 13th question. Write the first 5 terms of the following sequence and obtain the corresponding series. a1 is equal to a2 is equal to 2. an is equal to an minus 1 minus 1. n greater than 2. Here, first 2 terms are given to us. First term is 2, second term is also 2. And the third onwards only you have to calculate. N greater than 2 means n you can put 3, n you can put 4, and you can put 5. And calculate. This you will try it as homework. Next we shall discuss the 14th question. The Fibonacci sequence is defined by 1 is equal to a1 equal to a2 and an is equal to an minus 1 plus an minus 2, n greater than 2. Find an plus 1 by an for n is equal to 1, 2, 3, 4, 5. Here Fibonacci sequence we have already discussed in the beginning. First 2 terms are 1 and the third term onwards it is getting by adding the previous 2 terms. an is equal to an minus 1 plus an minus 2. One term is getting by adding the previous 2 terms from third term onwards. First 2 terms are 1 itself. Then here find an plus 1 by an for n is equal to 1, 2, 3, 4, 5 means n we have to put 1, 2, 3, 4 and 5. So the first we have to calculate a1, a2, a3, a4, a5 and a6. It is given that a1 is 1, a2 also 1 from the given condition. an is given, an is an minus 1 plus an minus 2. That is for n greater than 2. 3 onwards we can use this. 3 onwards we can put as value of n. So putting n is equal to 3, a3 is equal to a3 minus 1. It is on suffix, it shows the position. a3 minus 1 plus a1 minus 2. That means a2 plus a1. a2 and a1 both are 1 each. So 1 plus 1 that is equal to 2. Then n is equal to 4. Then n is equal to 4. First we put 3, the next is 4. a4 is equal to a4 minus 1. n minus 1 means 4 minus 1 plus a4 minus 2. That means a4 minus 1 is 3. a3 plus a2. a3 we have 2. So 2 plus a2. a2 is 1. So 2 plus 1. 2 plus 1 is 3. Next is n is equal to 5. a5 is equal to a5 minus 1 plus a5 minus 2. So 5 minus 1 is a4 plus a5 minus 2 is a3. a4 is there with us 3. then A3 is there with us 2, so 3 plus 2, that is equal to 5. Next is putting n is equal to 6. A6 is equal to A6 minus 1 plus A6 minus 2. So A6 minus 1 is A5. A5 plus A4. A5 is there with us 5. A4 is there with us 3. So 5 plus 3, that is 8. So A1 is 1, A2 is 1, A3 is 2, A4 is 3, A5 is 5, and A6 is 8. Dear students, today we have discussed the basic concepts of sequence and series, and we have solved questions from exercise 9.1. Go through the definitions and the problems while practicing. If you have any doubt, note it and keep. We will discuss it during the discussion session. Thank you for watching.